From a distance, the Sun and the planets of the solar system appear to occupy only a tiny space, so small that you could easily fit all of them inside a sphere large enough to encompass even Neptune's orbit. The outermost planet in the solar system has a total volume that is extremely small compared to the surrounding space. If you combine the Sun, all the planets, and their moons, they occupy just over 1/1,000,000,000th of the volume of space they encompass. Upon closer observation, the space between planets is actually filled with rocks, debris, ice chunks, cosmic dust, charged particles, and streams of thin gas ejected outward. Space is not filled with magnetic fields or grand gravitational fields either. Plow through. Most of them are only as small as grains of sand. Nearly all of them burn up when passing through Earth's atmosphere. Because the arms swung through the air with excessive force, the fragments instantly vaporized upon impact. Our fragile human species evolved beneath this protective shell. After melting halfway, the larger chunks of ice, roughly the size of baseballs, heated up quickly but unevenly and often shattered into smaller fragments before fully evaporating. Beneath the thick layer of ice, the surface will be scorched. But aside from that, they still lay flat against the ground without a single crack. Perhaps you're thinking that, after 4.6 billion years orbiting the Sun up until now, the flames cleanly consumed every fragment that might have lain in their path. However, there was a time when the circumstances were far more tragic than this. Within 500 million years since the Sun and the planets in the system formed, goods tumbled down, debris scattered everywhere, flames roaring fiercely on the ground, to the point where the heat generated from continuous collisions heated the atmosphere and melted the Earth's crust. Complex organic molecules cannot form. Notably, a large fragment from the collision played a crucial role in the formation of the Moon. The unexpected scarcity of iron and other heavy elements on the Moon, which we inferred from the samples brought back by the Apollo astronauts. Research indicates that the Moon may have formed from Earth's crust and upper mantle, regions that are iron-poor. After a collision with a primordial planet the size of Mars, the debris in orbit from this collision often combines to form our adorable low-density satellite. This is not uncommon when compared to other large planets and celestial bodies in the solar system. All must bear the same losses. Due to the lack of atmosphere, the surfaces of the Moon and Mercury are not eroded, preserving many traces. The craters from this period are not just marks on the solar system left by wandering objects colliding during its formation. The space to reach that planet must also contain all kinds of rocks of various sizes. The Moon and Earth were ejected from the Sun after being flung from its surface during high-energy collisions. Computer simulation studies of asteroid impacts have clearly demonstrated that the rocks on the surface near the impact zone could be ejected at a velocity high enough to escape the object's gravitational pull. In the current context, we are discovering an increasing number of meteorites originating from Mars that have fallen to Earth. According to research, an estimated 1,000 tons of Martian rock fall to Earth each year. Perhaps a similar amount also reached Earth from the Moon. Come to think of it, there's no need to fly to the Moon just to bring back rocks. The stone rolled to me naturally, though I had no desire to pick it up. During the Apollo program, we were completely unaware of this. The majority of asteroids in the solar system are concentrated and orbit within the main asteroid belt, a relatively flat region of space located between the orbits of Mars and Jupiter. By convention, explorers have the freedom to name the asteroids they discover. Artists often depict this place as a rugged, uneven land, suspended in the plane of the solar system. But the total mass of the asteroid belt is less than 5% of the Moon's mass. But this mass accounts for just over 1% of Earth's mass. It may sound trivial, but those accumulated deviations will gradually turn into an inextricable mess. It could involve thousands of asteroids, moving in strange orbits and crossing Earth's path. According to preliminary estimates, most of them will collide with Earth within the next 100 million years. Objects wider than about 1 kilometer in size, upon collision, would release enough energy to destabilize Earth's ecosystem, and driving most creatures on Earth's surface to extinction. That is truly tragic. Asteroids are not the only cosmic danger threatening life on Earth. The Kuiper Belt is a meteoroid belt, a region containing floating fragments of asteroids in space. Starting from the outermost ring of Neptune, including Pluto, from which extends a distance perhaps equivalent to that from Neptune to the Sun. The Dutch-American astronomer Gerard Kuiper hypothesized that in the deep, frigid regions of space, beyond Neptune's orbit lies the realm of scattered objects, remnants left over from the formation of the solar system. There is no collapsing planet to fall into, so most of these drifting stars will continue to orbit the Sun for billions of years to come. Just like the asteroid belt, some objects in the Kuiper belt follow unusual orbits. Cross the orbit of another planet. The orbit of Pluto and similar dwarf planets, called Plutinos, crosses Neptune's orbit as they move around the Sun. Other objects from the Kuiper belt plunge into the inner solar system, swiftly crossing the orbits of the planets. This small group has Honla as its most famous star. Beyond the Kuiper belt, stretching roughly halfway to the nearest stars, lies a spherical drifting star horde known as the Oath Cloud. Named after Trang Oath, the Danish astronomer who deduced its existence. This region explains why some shooting stars appear with long tails. Those drifting stars have rotation cycles far longer than a human lifetime. Unlike the drifting stars in the Kuiper belt, Oath cloud drifters can penetrate the inner solar system from any angle and direction. The two brightest stars of the 1990s, Han Bop and Hyakutake, both originated from the Oath cloud, and it will be a very long time before they can return. If the human eye could see magnetic fields, Jupiter would appear 10 times larger than a full moon in the sky. Spacecraft intended to explore Jupiter must be specially designed to withstand the planet's extremely powerful magnetic field. As the British physicist Maitreya Faraday demonstrated in the 19th century, when you pull a steel wire through a magnetic field, you will create a voltage difference along the length of the steel wire. Therefore, the space probe moving at high speed through metal can generate an induced current inside. This current also generates its own magnetic field to interact with the surrounding magnetic field, helping to maintain the spacecraft's motion. Perhaps this is the reason why the two Pioneer spacecraft mysteriously slowed down as they left the solar system. Both Pioneer 10 and 11, launched in the 1970s, did not travel as far into space as our dynamics and kinematics models predicted. To avoid the negative effects of cosmic dust during the journey, as well as dust residue from leaking fuel tanks. In this case, the idea of interaction between words and the Sun's magnetic field is perhaps the most plausible explanation. In the solar system, scientists have discovered a total of 214 natural moons orbiting various planets. In some ways, the moons in the solar system are even more fascinating than the planets they orbit. The two moons of Mars, Phobos and Deimos, were mentioned in the Adventures of Lemuel Gulliver in the 1727 classic by Jonathan Swift. Two potato-shaped moons Wern. Earth's moon has a diameter of about 1/300th that of the Sun, but it is also about 1/300th as far from us as the distance from Earth to the Sun. The Sun and the Moon appear to be the same size when viewed from Earth. No similar coincidence has been found in any other planet-moon combination in the solar system. The Earth is also tidally locked with the Moon, causing it to always face one side toward us and orbit the Earth in a stable cycle. No matter where or when this phenomenon occurs, a tidally locked moon always keeps the same side facing its host planet. Jupiter's moon system is a collection of astonishingly ancient objects. Wow, Io, the moon closest to Jupiter, is tidally locked and subjected to intense stretching forces due to interactions with Jupiter and other moons. Through this, enough heat is transferred to the small sphere to melt the ice inside. Io is the site of the most intense volcanic activity in the solar system. Jupiter's moon Europa has an abundant amount of water, thanks to a heating mechanism that melts the subsurface ice, forming a warm ocean beneath its surface. Surface, one of Uranus. It can't be pieced back together whole, like this wretched moon that once shattered and was forced to drag its fragments back together in a strained embrace. The origin of these peculiar features remains a mystery, though it may stem from a simple cause, such as uneven drifting ice blocks. Charon, the only moon of Uranus, is so large and orbits so close to the planet that the two are tidally locked to each other. Their rotation period and orbital period are the same. By convention, the moons are named after figures in Greek mythology associated with the corresponding Roman deity, after whom the parent planet is named. The ancient gods led richly diverse social lives, so there is no shortage of figures whose names we can borrow. Except for one special case, the moons of Uranus. They are named after the protagonists in English literature. The English physicist William Herschel was the first to discover a planet beyond the range of naked eye observation. Thus, he was willing to name the new planet after the king to whom he pledged his unwavering loyalty. S. proposal to name the moons after characters from William Shakespeare. Among its 17 moons, we can mention Ariel, Cordelia, Desdemona, Juliet, Ophelia, Portia, Puck, and Umbriel, along with two newly discovered moons, Cupid and Perdita, found in 1997. Material from the Sun's surface escapes at a rate of 200 million tons per second. The Sun loses this mass through solar wind, streams of high-energy charged particles traveling at speeds of up to thousands of kilometers per second. These particles stream through space and are deflected by the planet's magnetic field. Charged particles move toward the magnetic north and south poles, colliding with gas molecules in the atmosphere, causing them to glow and form the colorful aurora phenomenon. The Hubble Space Telescope has detected auroras near the poles of both Mercury and Jupiter. On Earth, the northern lights and southern lights always remind us of how wondrous this protective atmosphere truly is. Earth's atmosphere is often described as a thick layer of air, tens of kilometers deep, enveloping the planet. Satellites in low Earth orbit typically travel at speeds between 150 and 650 kilometers per hour and complete one orbit in about 90 minutes. Though unable to breathe at this altitude, some atmospheric molecules still remain, enough to gradually deplete the rotational energy of unprotected satellites. To counteract this slowing effect, satellites in low orbit must be continuously maintained. Otherwise, they will fall back to Earth and burn up in the atmosphere. The most reasonable way to define the boundary of Earth's atmosphere is to identify the point where the density of gas molecules equals the density of gas molecules in interplanetary space. By this definition, Earth's atmosphere extends thousands of kilometers into space. Telecommunications satellites operate above this level, at altitudes over 38,000 kilometers. At this particular altitude, Earth's atmosphere no longer has a significant effect, but the satellite still moves slowly enough to complete one orbit around the Earth in 24 hours. These satellites have orbits that match Earth's rotation speed, so they appear to stay in a fixed position in the sky. As a result, they are also the ideal solution for transmitting signals from one area to another on the ground. Earth's law of universal gravitation states that although a planet, Jupiter, with its immense gravitational force, has pushed countless asteroids away from dangerous orbits, preventing them from threatening the inner planets of the solar system. Jupiter acts as a gravitational shield, protecting Earth and helping our planet maintain peace and stability over long periods of time. Without Jupiter's protection, complex life would struggle to thrive as it does today, constantly facing the threat of extinction from catastrophic collisions. We have utilized the gravitational force of planets to launch the majority of probes and satellites into space. The Cassini probe on its way to Saturn, for example, was launched from Earth on October 15, 1997. After launch, it received gravitational assists from Venus twice, Earth once, and Jupiter once. Like a billiard shot, where the ball hits multiple rails before sinking into the pocket, a spacecraft's path weaving between planets is entirely normal. To harness the supporting force, our tiny probes 1.